Alright, so in this video, we're going to be talking about trigonometric functions. As you guys heard already before, the term sine, cosine, and tangent. These are identities or trigonometric identities in which you use to find the ratio or to find specific measurements of a right-angled triangle given that you have an angle and a side, or two sides and you want to find the angle, right? You can use the algebra there to work out the side lengths or the area or the angles of a right-angled triangle. And of course, not always a right-angled triangle, because there's some things that we call the law of cosines and the law of sines, in which we use some specific occasions, in which I'm going to be talking about later out of this course, because in this course I'm just going to be talking about functions, right? But so we have sine, cosine, and tangent. When we're graphing this, we always have a parent graph, or like a graph without any transformation for each one of these. But before this, I want to give you guys some overview of what I'm going to be talking about in this unit involving trigonometric functions. You guys know that the reciprocal of sine is something that we call cosecant. Right? The reciprocal of cosine is what we call secant. And the reciprocal of tangent is what we call cotangent. So you guys are going to see that the reciprocals of each one of these are connected in some kind of way when we're graphing them. So in this video, we're only going to be talking about how to graph sine. In the next video, we're going to be talking about how to graph cosine and then tangent. But pay close attention to how to graph these, because if you don't know how to graph these, you won't be able to graph these other three, which will be our following videos, right? So let's get with the parent graph of sine. So when we're graphing sine, the parent graph is y, as you know, f of x function equals sine of x. This is the raw parent graph, right, with any transformation, right? And the standard form, or the general form of a trigonometric function in general, is y equals a sine, or if it's cosine, or if it's tangent, or whatever, or cotangent, whatever, it's here, the identity, right? So I'm going to put I there. And then we have brackets, bx minus c plus d. You guys probably know what these represent, right? Especially the c. C's gonna tell you if your graph is gonna shift to the left or to the right, and D's gonna tell if your graph is gonna shift up or down. B is gonna tell you usually if your graph is gonna reflect over the y-axis or not. And A, something special, is what we call the amplitude. It's gonna tell the amplitude of a graph. If it's gonna where our maximum and our minimum point will be, right? And if we're going to have a reflection over the x-axis. And also, this A right here will tell us if your graph is going to be compressed horizontally or stretched horizontally, right? In terms of the amplitude. Right, so let's just graph the sine. Right, so we have our coordinate plane, right? We don't have to necessarily do the fourth coordinate plane, because we're always going to the right, and we know that here there's no need for negatives, right? But when you're dealing with the negative, then you have to start from your negative coordinate and you go towards the positive. But in this case, I can see there will be no negative, so I can straight start from my positive coordinate, right? So our amplitude is going to be the absolute value of A, right? In which the absolute value of 1, right? There's a 1 here. Whenever you don't see a number, it's always being multiplied by 1. So do the absolute value of 1, which equals 1. That's our amplitude. And then we do our period. Our period, right? Trust me, guys, if you don't know this part, you won't get nothing. So the rest. I'll go over these terms later on. But the period formula is 2 pi divided by your b. And then we have the x scale, which equals your period divided by fourths. And I'm going to explain all of this why. And then later on, you have your phase shift, which is your bx minus c equals 0. And then you have your d, or your vertical translation, which is just your d, right? These are all the points that you have to know when graphing a trigonometric function for every single step, right? So let me explain this parent graph. In our next video, we're going to be doing cosine and sine with more transformations, right? Because in this video, I just want you guys to understand how this works. So this is our origin, right? 0, 0. As we saw this before. We know this. The parent graph of a sine looks, this will be pi halves. This here will be pi. This here will be 3 pi halves. And this right here will be 2 pi. Sorry. Right? So in the sine graph, you have to know how it looks like. It starts at your x, it starts here, it goes up to its maximum, and the maximum is 1. Sorry. It's 1 and minus 1. And this is the amplitude of the graph as well. So it goes up to its maximum, back to its intercept, down to its minimum, right, to this -1, and back to the x-axis. This is how a sine graph looks like. Of course, we're going to look a lot of reflections, our transformations, all this we'll be covering in our next videos. But this is how the parent graph, this is what this looks like. And that's how we come up with the formulas later on, because one thing that I want you to realize, the amplitude is always going to be the absolute value of A. That never changes. That you have to memorize, right? In this case, absolute value of 1 equals 1. And then the next thing is our period. We can see that our period here, the length, as we see, of the graph is 2 pi, right? If we add another 2 pi, that's when our second period is going to finish. So if you add 2 pi to each of these numbers right here, it's going to be where these points are located in our next part of the graph. Because you know that these graphs, they go on and on and on forever. They're infinite, right? Just like a linear line or a quadratic, they go on and on forever. And when you're graphing these, you always need to graph at least 2 periods. And what does that mean? You always need to have at least 9 points, right? You're starting, and then 4 periods, and then 4 periods. So you always need 9 points in total when graphing these trigonometric functions, right? And one thing that I want to say is that this period is like the length of your first graph, in which if you add 2 pi to this, you have the finishing again. If you add 2 pi to this, you have where this starts, right? So this is what I'm trying to say. Your period is going to tell you the length of a graph, where each point will be located terminally, right? How you can measure one period, one sequence, right? This is a period, one sequence, one graph. And then the next thing we talked about was the x scale. Now, the x scale, we said we divide our period by fourths, right? And why do we divide our period by fourths? We know that we have our length of our graph, right? We have that point of how much the length of each graph is. So if we divide our period by fourths, we can see that here we have 4 major points. We have spaces, right? We have 1 space, 2, 3, and 4. We have 4 major spaces. So if we have our period, for example, 2 pi, and we fourth it, we're going to know the value of each single number. We're going to know how much each one of these numbers are worth, right? So that we can find our next point in terms of this format, right? So if we have our period 2 pi and we divide it by fourths, right? 2 pi divided by fourths, we know this cancels out. So we're going to have pi halves. So we know that if I add pi halves to this, I get pi. Pi plus pi halves, 3 pi halves. 3 pi halves plus pi halves is 2 pi, right? That's where we get our x scale. And then our phase shift, in this case, we know it's nothing, right? Because what is our bx minus c equals 0? We only have this case x equals 0. So we know that our graph is not shifting left or right. And this is just, you need to memorize. And this is, with the phase shift, you can also find your start and your end, right? If you put your bx start is your bx minus c equals 0, and your end is bx minus c equals 2 pi, right? Because that's where our first period finishes, right? That's the parent graph for your trigonometric function. So that's how you can sort of estimate where your finish is going to be because of where your period is at, right? And this is it, guys. Thank you all for watching.